Hello everyone, I am Anupam Gohai and I welcome you all to this session on graphics in Scilab. Today we will explore how Scilab, a powerful open source software, helps us visualize and analyze data effectively using its robust graphics capabilities. From basic 2D plotting to advanced customization and data visualization, Scilab offers tools that simplify complex computations and make data interpretation easier. Our focus will be on understanding the importance and applications of graphics in Scilab, learning to create 2D plots and customizing them to suit specific needs. This lecture will be with examples and demonstrations. Let's dive into the exciting world of graphics handling in Scilab and unlock its potential for your projects and research. Graphics in Scilab are tools that help us create visual representations such as plots, charts, and graphs. These visuals make complex data easy to understand and allow us to analyze trends and patterns more effectively. Scilab integrates these capabilities seamlessly with built-in functions to create both 2D and 3D visualizations, making it a powerful tool for data analysis. Scilab graphics offer support for both 2D and 3D visualizations, enabling us to create various types of plots including line charts, bar graphs, and surface plots. These plots are highly customizable. We can change colors, add titles, labels, and legends to make the visuals more informative. For advanced formatting, Scilab provides options to include grids, annotations, and other details to make our visualizations clear and professional. Here's an example of a 3D surface plot showcasing how Scilab simplifies complex data. Graphics play an essential role in helping us understand information more easily. They turn raw data into visuals that are quick to interpret and analyze. For example, weather forecast use charts and maps to display temperature trends, make it simple for anyone to understand. Similarly, in stock market analysis, graphs show how prices fluctuate, helping investors make decisions. These are just a couple of real world applications that show the importance of graphics. Graphics are important because they simplify complex data. For example, instead of going through long tables of numbers, a simple chart can convey the same information instantly. They also enhance presentations and reports, making them look professional and engaging. When we use visuals, our message becomes clearer and the audience connects better with the information. Graphics have wide-ranging applications. In data analysis and visualization, businesses use charts to find trends and make decisions. In scientific and engineering fields, graphics help researchers visualize simulation results or experimental findings. Lastly, in education, teachers and trainers use visuals to explain difficult concepts, making learning interactive and effective. These applications show how graphics are a very vital part of various fields. 2D graphics are visuals that display data using two axes, X and Y. These are commonly used to represent relationships, trends, or comparisons. For example, Line plots are great for showing trends over time. Scatter plots help in visualizing relationships between variables. And bar charts are useful for comparing categories. These type of plots are widely used in analysis and presentations. Scilab makes it easy to create 2D graphics for various purposes. For instance, you can use a line plot to display trends like showing sales growth over several months. Similarly, bar charts are perfect for comparing data sets such as the performance of different departments. These examples highlight how 2D graphics in Scilab help in presenting data effectively and clearly. Scilab provides simple commands for creating 2D plots. The plot xy command generates a basic plot where x and y are data points for the x and y axis. For more control over the style, like line colors, markers, or thickness, we can use the plot 2D XY style command. This allows us to enhance the visual presentation of our plots. Here is a simple example of creating a 2D plot in Scilab. In this code, we first define x as a range of various values from 0 to 10, incrementing by zero point 0.1. Then we calculated y as the sign of x. Finally, we use the plot xy command to plot the sine wave. This demonstrates how easy it is to visualize mathematical functions in Scilab using just a few lines of code. Scilab provides different types of 2D graphs for various purposes. Line plots are great for showing trends or continuous data and can be created using plot xy command. Scatter plots created with scatter xy command are used to display individual data points and their relationships. Bar charts generated with bar xy command are ideal for comparing categories or groups. These type of graphs make data analysis and presentation more effective. Now we'll create a simple 2D plot in Scilab. We'll plot a sine wave, which is a commonly used function in mathematics and engineering. First, we need to define the x-axis values. In Scilab, we use a range of values for x. Let's type x equal to -2 pi 0.1 to into pi. Here we are creating an array of x values from -2 pi to 2 pi with a step size of 0.1. This ensures smooth plotting of the sine wave. Next, we will calculate the y values using the sine function. Here, this line takes each value of x and applies the sine function to it, generating the corresponding y values. Now let's plot the sine wave using the plot function. This command will generate a basic plot of y versus x. A graph without a title looks incomplete. Let's add a title using the title function. Next, we need to label our axes so that the graph is more informative. Here, x level defines the label for the horizontal axis as x-axis and y level defines the vertical axis label as y-axis. Now we save the code. Let's run the script and see the output. You can see the sine wave plotted from minus 2 pi to 2 pi. The curve is smooth because we used a small step size of 0.1. Here, in this example, we learned how to define x values using a range, how to compute y values using the sine function, how to plot the graph using plot xy function, how to add a title using title, how to label the axis using x label and y label. This is the basic way to create 2D plots in Scilab. From here, we can explore more advanced plotting techniques. Now, we will create a scatter plot in Scilab. Scatter plots are used to display data points and analyze relationships between two variables. This is useful in data visualization and analysis. In this example, we will generate random data points and plot them using the scatter function. First, let's generate 20 random values for the x-axis using the grant function. Here's what happens in this command. The grant function generates 20 random integer values between 1 and 100. These values are stored in the variable x, representing the horizontal axis of our scatter plot. Now we generate 20 random values for the y-axis. Just like before, this creates 20 random numbers between 1 and 100, but this time for the y-axis. So now we have two sets of random numbers, one for the x values and one for the y values. Now let's plot these points using the scatter function. This function plots the x and y values as individual data points on the graph. The field diamond option makes the markers field diamond. A title helps us understand what the graph represents. Let's add one using the title function. Now the plot will be labeled scatter plotted plot example at the top. To make our graph more meaningful, we add labels to the axis. Here, x label sets the label for the y-axis as random x values and y label sets the y-axis label as random y values. Now, let's save the code and run the script and see what the scatter plot looks like. You can see that random points are scattered across the plot. Since we used random values, the pattern will change each time we run the code. In this hands-on example, we learned how to generate random numbers using the grand function, create a scatter plot using the scatter function, and customize the plot by adding a title and axis labels. Scattered plots are very useful when analyzing relationships between two variables. For example, they can be used to study trends in data such as sales and advertising spend, height versus weight, or test scores versus study hours. Now, we will create a bar chart in Scilab. Bar charts are used to compare values across different categories. They are commonly used in data analysis reports and presentations. In this example, we will compare student marks in different subjects using a bar chart. First, we define the subjects for which we have marks. We use a list of subject names. This stores the subject names in an array. Next, we define the marks obtained by the student in these subjects. This array contains the marks for maths, physics, chemistry, and English respectively. Now we use the bar function to create a bar chart. This command generates the bar chart where each bar represents a subject's marks. To make the graph clear, we add a title using the title function. We also need to label the axes to show what they represent. Here, x level and y level sets the x-axis level as subjects and y-axis level as marks. This helps in understanding the chart better. Now, let's save the script and run the script and see the bar chart appear on the screen. You can see that each bar represents a subject and the height of the bar indicates the marks obtained. This is an easy way to compare data visually. In this hands-on, we have learned how to define categorical data, that is subjects, plot a bar chart using the bar function, add a title and axis levels for better understanding. Bar charts are widely used for data comparison such as sales reports, survey results, and student performance analysis. Scilab also supports advanced plotting features. You can overlay multiple plots in a single graph by plotting multiple datasets together using separate plot commands. Additionally, the subplot command allows you to display multiple graphs in a single window. You can divide the window into rows and columns and specify the position for each graph. These advanced features help in presenting complex data efficiently. Now, let's take a moment to check your understanding with a couple of quick multiple choice questions. This will help you review and solidify the concepts we have covered in this tutorial. Here is the first question. Now, here is the second question. If you answered correctly, great job. If not, don't worry. You can revisit it, the explanation in the video to clarify your understanding. Let's move on to the next section. In Scilab, you can easily customize your plots. You can add a title using the title command, which helps describe what the graph represents. To label the axis, you can use X label for the horizontal axis and Y label for the vertical axis. Finally, X grid command adds a grid to the plot, making it easier to read and interpret the data. Scilab provides several formatting options to enhance your plots. You can customize line styles, markers, and colors using the plot 2D command, allowing you to make your visuals more appealing. To explain multiple plots on the same graph, you can add a legend using the legend command, making it easier to differentiate between them. You can also control the range of the axis using X limb and Y limb, which lets you zoom in on specific parts of the graph. These features make Scilab plots highly flexible and professional. In Scilab, you can easily plot mathematical functions such as sine, cosine, and exponential. These are commonly used to visualize mathematical relationships. For simple plots, you can use the plot command. If you need more control or want to create parametric plots, the plot 2D command provides advanced options for customization. Here is a simple example of plotting a sine wave in Scilab. First, we define x as values ranging from minus 2 pi to 2 pi with small steps of 0.2. Then we calculate y as the sine of x. The plot xy command generates the sine wave. We add a title using title and label the axis with xlab for the x-axis and ylab for the y-axis. This code produces a clear and labeled sine wave graph, making it easy to understand the function visually. In Scilab, you can create plots directly from data files. Data can be imported using commands like read for text files or CSV read for CSV files. After loading the data, we can use the plot command to visualize it. Just select the appropriate columns for x and y axis and Scilab will generate the graph. This feature is useful for working with real-world datasets. Here's an example of plotting data from a CSV file. First, we use the CSV read command to load the file named data.csv. The data is stored in a variable called data. The plot data colon 1 data colon 2 command takes the first column as the x-axis and the second column as the y-axis, and it generates the plot. This approach is simple and allows you to visualize data quickly and effectively. Now we'll learn how to plot data from an external file such as a CSV file. This is useful when dealing with real-world datasets like sales data, experimental results, or stock market trends. We will read a CSV file and visualize the data using a simple plot. Before we start coding, let's understand the file format. A CSV file is a comma-separated values file which stores data in tabular form, where values are separated by commas. For example, our file data.csv contains two columns. The first column represents x values and the second column represents y values. The first step to read the CSV file using the CSV read function. This command loads the data from data.csv into a variable named data. Now we extract the first column as x values and the second column as y values. Here data column comma 1 refers to all rows in the first column and data column comma 2 refers to all rows in the second column. The plot function then creates a graph using these values. To make our graph more meaningful, let's add a title and label the axis. Now the graph has a title and clear axis labels, making it easy to understand. Let's execute this script and see the output. Now we can see that the data from our CSV file is plotted as a line graph. In this hands-on, we covered reading data from an external CSV file using CSV read, extracting and plotting values from the dataset, and adding a title and axis labels for better visualization. This method is very useful when working with real-world datasets such as weather reports, financial trends, or scientific measurements. Before we wrap up, let's quickly check your understanding of the concepts we have learned. Here are two multiple choice questions for you to think about. If you got it right, excellent. If not, you can revisit the explanation in the video. Here is the next question. Well done if you have answered correctly. If not, don't worry. You can always revisit the explanation in the video to review. Great work on those questions. Now, let's summarize everything we have learned in this session. Today, we have explored the essential role of graphics in simplifying data analysis and enhancing visualization. We began by understanding the fundamentals of graphics handling in Scilab and its importance in various applications. From here, we delved into 2D plotting, learning basic commands like plot and plot 2D, and creating different types of graphs including line plots, scattered plots, and bar charts. We also examined the extensive customization options available in Scilab, enabling us to format and style our plots with titles, labels, legends, and axis adjustments. Furthermore, we saw how Scilab handles function plotting and how to visualize data for external sources like CSV files. The ability to represent data graphically not only emphasizes clarity but also adds a professional touch to your analysis and reports. Whether you are working on academic projects, engineering projects, or research papers, Scilab's graphic tools are indispensable for creating meaningful insights. Before we conclude, I would like to leave you a reminder. Effective graphics are not just about making things look good. They are about making data more accessible and actionable.